I'm Eleonora Giunchiglia, and I just finished my PhD at the University of Oxford, and I started my postdoc at the TU Vienna. IJCLR. So the basic idea was that we wanted to create a platform to make deep learning models safer. How can we make deep learning safer? We can start writing requirements for them, right? So that as we do for standard software, right? In standard software, you have a phase where you write requirements and then you write software compliant with the requirements. Now, I would like to do the same for deep learning, but to create deep learning models with requirements, you have a data set. You need to have a data set. So what we proposed in this paper was, first of all, the first data set for autonomous driving with requirements. So we actually annotated a data set for autonomous driving with logical requirements. And then we showed that if you just take a data-driven approach, then 90% of the predictions actually violate the requirements. So no matter the thresholds that you're using, at least to be precise, 89% of the predictions will violate these requirements. And then we proposed a couple of very basic approaches to incorporate these requirements into the training or in the post-processing phase to make deep learning models actually compliant with these requirements without dropping, obviously, their performance. Until I say 3 years ago, there was very much this approach that it was enough to have very high accuracy to avoid these problems. So when I was going to conferences, sometimes people were telling me, oh, but if we have 99.9% accuracy, then for sure neural network won't do this sort of stupid mistake, right? But then neural networks have started to be applied to more and more complex problems and to safety critical scenarios where even one single error can make really the difference, right? I think they were not built on an accurate basis. They were more built on a different assumption. So I think, like if we look at the history of AI, initially AI was very much deductive basis. So if we look at the work done in the 80s, in the 90s, people were thinking reasoning is enough, right? Then neural networks came along and people started thinking, oh, data is enough, right? So we just need to have data. And now I think we are getting into a new phase where people start thinking, okay, we need both reasoning capabilities and we need to learning capabilities. I hope so. So for sure, things are already changing. So it's not like just my work. There is this entire new neurosymbolic wave that is happening. What I hope, like my tiny contribution will be, is to actually say, we need the reasoning not only to improve performance or to learn from less data, but we also need it for safety reason. And we can learn some lectures from standard software engineering and from logic and just apply them in neural networks in deep learning. We don't need to reinvent the wheel, right? The real shock for me came when we saw the results of the number of violations, because if I have to be honest, I was expecting some violations of the requirements, and since we annotated in the hundreds, I was expecting a lot of violations, but something in the I don't know, 20%, 15% of the predictions having at least the violations. When I saw 90%, I was really in shock. And I remember checking the results, I don't know, for a week. I rerun the entire pipeline multiple times because I couldn't believe these results, right? Because I think the entire point is that a lot of people, when working with the idea of logical constraints, they just annotate one or two. And then it's normal when neural network violates these requirements one or two times. But when you start having hundreds of requirements, then it's natural that this percentage really increases. Now, 90% was a shock. I think what was interesting for them was having a clear application domain. So a lot of these neurosymbolic methods are very powerful, but they are still applied to toy data sets, while our work sort of bridged this tiny gap between like theory and practice. And that's all it did. It was just, okay, let's port this neurosymbolic word into the real world and see how it performs on a real world task, on a safety critical task. I hope that in the future, we will start having requirements, elicitation, and specification for deep learning, also for, like, as normally happens for software, like development of software. And I think if this message really passes, then we'll have much safer models, and like nobody will lose anything. Essentially, I'm still working on the same problem. There is so much to do. That's another takeaway message. Like, this problem is still very much understudied. So how to incorporate hard logical constraints requirements, there is a world to explore. So now I'm just going on and working more on this task, essentially.